Hello. Hello and welcome to this video on SQL with PostgreSQL. So we will resume where we stopped in the last video. So in this video, I have added two more rows to our table books. In one row, we have the book name textbook written by Note, ISBN 1002, price 50 and 40 copies. And in the last row, it is my book, a variable in algebra. I'm the author. And ISBN is 1003. There is no price. It is free. And there are no copies because I don't intend to publish hard copies because hard copies will definitely have some price. Okay. So now if I select it from the books, I have this as the output. So one of the things which can go wrong is that this ISBN while we are inputting may be duplicate. So while the ISBN number of actual books are unique. So one of the ways to prevent that is you create a unique index like this. Create unique index ISBN underscore IDX on books ISBN. So we create this index. Okay. So our index is created. Now, suppose I want to insert another row. I will just put the same row as this. ISBN is same, but there is no unique index on book name or author one, so that should be fine. Now, I should try to run this. It will say duplicate key value violates unique constraint ISBN index. Key ISBN 1003 already exists. Duplicate key value violates unique constraint ISBN index. So this is very useful when you want to have a unique column. So for that unique column, you should define the unique index. Now, this index serves two purposes. One is that it does not allow duplicates. And second is you can query on the basis of this column ISBN. Now, once we have created an index, we may want to drop that index. We don't want that index. So the syntax for that is drop index price underscore IDX. So this will drop the index IDX. So if you run this, then it drops the index. Now suppose you want to drop the unique index, drop index ISBN underscore IDX, then this should drop our ISBN index. So both the indexes are now gone. We recreate them. So this is the syntax for dropping the index. We had already seen delete from books where ID is equal to 2. I don't remember whether I had told you this, but you should be careful when you do something like this. Drop from books. It will delete all the rows from the table. Okay. So for example, if we see right now, we have 1, 3, 4, 5, and we have 4 rows. So if we call this, then what will happen? You see, sorry, not drop, delete from books, delete from books. So you should not call this casually. So it deleted all 4 rows. It tells us delete 4. Now we'll have to recreate this. Now, if you try to look at the table, should be very careful when you do delete from. Delete from ideally should be always followed by a where clause. If you want to delete the entire table, it is much better to call drop table. We'll see about that. So we run this to insert. Now, if you see, the primary keys would have changed as discussed in the last video. We have now 7, 8, 9, 10. Now, if you want to delete the table itself, a better way to call is drop table books. This will delete your entire table. We'll run this and see. The table is gone. Now, if you see here, if you refresh, there are no tables anymore. So we recreate the table again and we create the rows also. So now if we refresh this, we have books and we have our columns. Now since the table was gone, the indexes are gone also. So we have to create the indexes also. Okay. When you drop the table, all the data associated with table indexes and data which you have will be gone. So we have seen the drop table. Now similarly, we have drop database, which I believe I have shown. So the drop database syntax is, I'll type it here, drop database followed by the database name test, and it will drop the entire database. So once you drop the database, it is gone forever. Okay, be careful with these drop and create indexes and all that. Now, suppose we have these many rows and we want to find out how many different authors are there. So what we can do is we can say select distinct author one from books. So this will select reverse Shiv note. So there are three different author ones. Okay. Similarly, you have some aggregation functions like price, max price. So this will tell us what is the maximum price we have. We have average price. Now, average price, if you see, is 46 here. Note that when I don't give a price, the column is null. And that column will not be accounted for if the price is null. So the average will be of the columns whose value will not be null. We take care of that. Similarly, we have min price and we have that. Similarly, you can have count. You can count the number of rows. So better way to count is you just count only one column. Okay. So if you count one column, it will be slightly faster. So that is, and then we have something like order by. So order by will order the columns by price. So note that this is ascending and null values will be at the last. So this is in general is ascending. By default, that is the case. If you want, you can have descending descending case as well. So now null values will be at the top and the price will be descending. So these are some of the things which we can do. Now suppose we want to remove this column author 4, it is not being used. So if you want to remove this column, you can have drop column. Now for a table, the command would be alter table drop column author 4. Author 4. Yeah. And then you run this. Oops. Okay. Alter table. Oh, we have not given the table name books. So it dropped the column author 4. Now if you want to see this, we do select star and the author 4 column is gone. So we remove that way. And then if you want to add the same column, alter table books, and we say add column, and then we say its data type was varchar 128 author 4. We give the name of the column and we say varchar 128. So now we will have our varchar there. Okay. Now one of the things which we need to do is sometimes change the data type. Okay. For example, let's say price. Okay, this price is empty here. So ideally, you should not convert data types which are not compatible. Like int values can be converted to big int or something like double. So if something is varchar, you should not try to convert int. So the way to do that is if you want to convert the price, for example, in this case, so you can say that alter table books, alter column, price, and we say data type. I believe this should be big int. This should work for us. Okay, set data type. So now it is a big int. Okay, and if you want to convert it back to int, now again you have to take care of the fact that if you are converting from big int to int, the conversion may not be proper because the value is out of range for int, because int is what, 4 bytes. So 4 byte means that is roughly minus 2 into 10 to the power 9 to 2 into 10 to the power 9, the approximate value. 2 into 1024 to the power 3. Negative of that plus positive of that. But big int would be up to 10 to the power 18. So if value is bigger than 2 into 10 to the power 9, then as a big int, then if you convert the column back to int, it is not safe to do so. So we run this and we have our data type back to int. Okay. Now in the where clause, we can say certain more things here. But by the way, one thing I did not explain is this distinct author. Be careful with these queries. It always performs a full table scan. Okay, be very, very careful with this. Similarly, max, average, min will do a full table scan to figure out, unless you have an index on it. If you have an index, it will be fetched pretty fast. Anyway, so for example, we have price. So ideally, since we are doing aggregation on that, it is best to create an index on that, price index on books price. So before creating an index, it won't be visible in this. But say, for example, it takes 54 milliseconds, 67, 55, 56. So it takes more than 50 milliseconds. It won't be visible in this example, but let's see. We created an index. Oh, we have a price index already there. Okay. Let me see. Okay. So we drop the index here. We drop the index and now we perform this. So it won't change much because it's a very small data set. So, but in large applications, you will see the difference of index and these max min kind of stuff. So similarly, count can be very expensive if you want to count it. Now we look at an AND clause. So we have selected book, the columns here where price is less than 40. And similarly, we can say that and author 1 is equal to note. Okay. So we want only books written by note here. So that's an AND clause. Okay. Column note data. Where is column ID book name author 1 books website. Author 1 is equal to note. So this should have been correct. Oh, this is not in double quote, single quote. Okay. So this will give us books from note. Okay. Now let me see why this did not come. Textbook should have come. Author 1 and Note is there. Note. Okay. Oh, price is less than 40. So there are two conditions. Price is less than 40 and author 1 is not. If we remove the price condition, then it will give both the books. But we want to have both the conditions. So in this case, it will give only one of the values. Now, what we want is, suppose what we want is, we want either the price to be greater than 40 or author is not. Okay. So in this case, you see what will happen. It gives us all three results. Okay. The reason is two books are written by note, and for introduction to algorithms, the price is greater than 50. But suppose we say that price is equal to 40, price is equal to, let's say, 50. Price is 50 or not. Then in this case, we will get three rows. So these two are for note, and the middle one is for price. Okay. So this is how you get the rows. Okay. And similarly, what we can have is author 1 is not note. Okay. Price is 50 and author 1 is not note. Then you'll, oh, this is not correct one. I forget that is not. Okay. Yeah. So in this case, the price is equal to 50 and author 1 is not equal to note. So in this case, the textbook comes because its price is 50, and these two come because the author is not note. But if you combine both the conditions, then you will see you will get only one row, introduction to algorithms, because it satisfies both the conditions. So I think I've covered quite a bit, and I will let you sleep on a bit and experiment with this much. And in the next video, we will come up with more complex queries and more concepts on SQL with PostgreSQL. I hope that I'm not going too fast, but these are very easy things. So with a bit of practice, you can learn this. And we'll see more complex queries in the next video. I hope that you're enjoying this series of video, and very soon we will have some of the DevOps and best practices of PostgreSQL. This won't be a big playlist, it will be a very small playlist. So thanks a lot for watching. Happy programming.